So, continuing on our potpourri stuff, again, remember that this stuff is not going to be quizzed or homework this week. However, it will be on your final, so I strongly encourage you to be taking some good notes on this because there are questions on simplifying radicals from earlier this week. There's inverse questions. There's one-to-one questions. Tomorrow's topic is a one-to-one function. Okay? So before we start on inverse functions, first off, I need to remember or remind you of function notation. Okay? So the name of a function is f of x. Okay? So f of x, or any letter of whatever variable you're dealing with. H of t, y of j kind of a thing. And that's function notation. The notation for an inverse is written as f to the negative 1 exponent of x. So, but it's said, okay, so that's what it looks like, but it is said the inverse of f. Okay? So it's written like that, but it's pronounced the inverse of f. Okay? So what we're going to be doing today is we're going to be given a function and we're going to find the inverse. Okay? So that's what we need to do. So let us do it. Okay? So the first thing that you are going to do when you have function notation is you are going to switch it back to equation notation. Okay? So you're going to first change the f of x into y. So if my function is f of x equals 4x plus 2, I would make that the y equals 4x plus 2. So that's the first thing that we do. Okay? If it's in function notation, we get it out of function notation and back into just equation notation. Okay? Then, the second thing you're going to do is you're going to switch the positions of only the x and the y. Okay? So, wherever there's a y, you rewrite it as x. Wherever there's an x, you rewrite it as y. So in this particular case, it would become x equals 4y plus 2. You just flip-flop the position. Okay? Then what we're going to do is we're going to take our new green equation and we're going to solve that for y. So first I would subtract 2. That would give me x minus 2 equals 4y. Then I would divide both sides by 4. And that would give me x minus 2 divided by 4 equals y. And then lastly, we undo, if you will, our first step. So we were going to switch it back from equation form into function form. But now this function is our inverse. So the process to do to find the inverse is relatively easy. You just switch the values of, or you switch the positions of x and y and solve for y. Is all you really have to do, but then we have to put it in the proper notation. Any questions about that? You tell me which one of those four is the inverse of f of x. So find me the inverse of f of x and tell me which one it is. So when I switch the x and the y, that's going to become x equals 3y to the 5th power minus 2. Add 2 to both sides. Divide both sides by 3. And take the 5th root of both sides. So I get the 5th root of the quantity x plus 2 divided by 3. I got that one as my inverse function. Agree? Love it. The composition property of inverses is used to prove if two functions are truly inverses. So there might be a question on your final that says f of x is this, g of x is this. Verify that they are inverses. Okay? Would be the question. And when you're verifying that they are inverses, you're proving that they are inverses, which means that you can't just do what we were just doing. Switch the x and the y, solve for y, all that fun stuff. Okay? This property has to be shown in both cases to prove that they are inverses. So the property is, if you take f of x and you plug it into g of x, you should get out just x when you simplify it. If you take g of x and you plug it into f of x, you should just get out x. Okay? So what that means is, I got there. This means that you have to put x into g of x, then put that result into f of x, and you have to put x into f of x, and then put that result into g of x. And you have to do both in order to prove that functions are inverses. You can't just do one. You have to do both. Okay? So let's try one. Okay? So verify that the functions below are inverses. Okay? So first off, I have to show that f of g of x is equal to x. So I have to take g of x and I have to put it in for x in f. So that would be f of g of x is going to be 4 times 1/4 x minus 1/2 plus 2. So I took my whole function g of x and I put it anywhere that there's an x in F. Well, now I can distribute 4 times 1/4 is 1 times x is x. 4 times negative 1/2 is negative 2. And then plus 2 at the very end. Negative 2 plus 2 is just x. So the first one is satisfied. Okay? But we can't stop there. Now, actually, I could have just tapped the brakes. Now, well, this color, the purplish, I have to put this in for x in the other one and show the exact same thing. So I'm now going to have to prove that g of f of x is also x. So that would be 1/4 then times 4x plus 2 and minus 1. Again, distributing. 1/4 times 4 is 1 times x is x. 1/4 times 2 is 2/4, which is reduces to 1/2. 1/2 minus 1/2 is just x. So because we've shown both of those, then we have the right to say that f of x and g of x are inverses. Yes, sir.
Should it always equal x?
Always equal x. If it equals something other than x, no doubt.
Even if it's like 3x, 2x.
It still be no, it's gotta equal x. Even if it's x plus 2, same thing. Yep. 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 You tell me if those two are inverses. Couple of head shakes. Yeah. So first we gotta try f of g of x, and that's gotta be equal to x. So I need to take this, put it in there. Distribute. 3 times 1/3 is 1 times x is x. 3 times 1 is 3. Then we got minus 1. So that gives me f of g of x is x plus 2. Is that equal to x? Nope. So these are not inverses. Okay. Both have to be true. F of g of x equals x. G of f of x equals x. Both of those have to be true in order to prove it. One of them has to fail in order to disprove it. Okay? So both have to show, or you gotta show both to prove. If one doesn't, no dice. Okay? So, what I would like you to do on this particular function is, there is f of x. F of x equals x cubed plus 1. First, I want you to find the inverse function. Okay? Then, I want you to verify, using the composition rule, that they are truly inverse. Okay? Go for it. Okay, so if I'm going to find the inverse, first thing I'm going to do is I'm going to first thing I'm going to do is I'm going to switch f of x to y. Then I'm going to switch positions with x and y. Then I'm going to solve that for y. So I'm going to subtract 1. And then I'm going to cube root both sides. So that's going to give me a potential inverse function of the cube root of x minus 1. Okay? So we were saying that then we need to prove or verify that, oops, there. So we need to verify that f of g of x is equal to x. Well, really what we're doing here now is f of the inverse of x, or f of the inverse of f needs to be x. So that would be, oops, that's x. So I would be putting in the cube root of x minus 1. Yeah. Cube root cubed makes the radical go away. So then this just becomes x minus 1, then plus 1, which is x. So that one verified. Now we've got to do the other one to full on prove it. So this is really the inverse of the function. Has to be x. So I'm plugging my function into the inverse. So my function was x cubed plus 1. And then we had a minus 1 in there also. 1 minus 1 is 0. So this is really just the cube root of x cubed, which is just x. So therefore we verified it. So this is, and I can say now with 100% certainty, that is my inverse of my function. Okay? Again, it's not just enough to find it, to switch the x and the y and solve for it. Okay? That's if we're solving for it, yes. But when the directions say, wink, wink, nudge, nudge, probably going to show up on a final somewhere. If the directions say verify, so I didn't go up far enough. If the directions say verify, you've got to show all of this. all of that is the verification. Yes, sir.
But like, if you've already found the inverse of it, isn't that kind of like repeating yourself?
It's proving that you're right. It's like a check. You know, back when we started second semester and we were doing systems of equations, and I said you can know you're 100% right by plugging these values back in. Okay? Okay? That's what we're doing. Okay? Again, I remind you that I am still waiting on a lot of missing work. If I had to guess, I would say that I am waiting on 9, 12, 26, 36, 49, 56, 76, 91,
Keep going.
109. I am waiting on 121 missing things just from this semester. Oh, wait, no, tap the brakes. That's just from Unit 7. Then we add in all the other ones. 10, 19, 29, 34, 46, 59, 70, 84, 88. So we are well over 200, or well over 200 missing things for this semester. Okay? Yesterday I gave you the day off to get some stuff in. How many things did I get?
0.
I got 1. At 1. Okay? Again, this class is college credit. Okay? Don't waste that opportunity. Yes, sir.
Are those actually missing, or are those?
Those are actual missing. That's just missing. That's not things that people need to fix. Yeah. Those are actual M's in the grade book. Mm-hmm. Okay. Okay. That's all I got for you today. Again, you have another mod to get stuff done.